Today is Unit 3, Day 3. So we've done quadratics written in vertex form. We've done quadratics written in standard form. And today we're going to do some early problem solving, and we're kind of going to do both forms here. So, first example, our first learning target, I can write the equation of a parabola given one point and the vertex. Okay, so we're going to tell you what the vertex is, we're going to tell you what a single point is, and you got to write the equation. I can find details about a parabola given in standard and vertex form. That's kind of a review of the last 2 days. And then I can use my knowledge about quadratic equations to solve max and min application problems. So remember, yesterday we talked about mins and maxes. Those are basically the y-coordinates of the vertex. So when you say max or mins, think y coordinates if I can spell correctly, of the vertex. So that second coordinate of the vertex is going to be a min or a max. So first problem here, we're going to do the first learning target. Given the graph to the right, so given this guy, write an equation in vertex form for the parabola. So first thing, vertex form, just a little refresher, it's going to be x minus h squared plus k. And some students will want to just jump straight to plug in this h and this k and circle it and be done. But remember, there's infinitely many parabolas that can go through this, that have that for a vertex. You know, it could be going through there, it could be a lot wider than that, it could be a lot skinnier than that, it could be open up. So there are tons and tons and tons of parabolas that can have that vertex. It's the A that will make it uniquely this one. Okay, so first off, go ahead and plug in your vertex. So I'll leave the A there because we don't know what that is yet. X minus my h is 3. So squared and then plus, and then k is 4. Now, again, that A is what's going to make it unique. And I can already tell it's going to be a negative A because this is open down. Okay, and what I got here, I've got 3 variables. I got y, a, and x. And the nice thing about this other point they gave us is there is an x and a y that go together. So here's an x and a y that go together. If I plug those in for x and y, the only thing left is a, and I'll solve and I'll be able to find my a. So this guy here, I'm going to plug in 5 for x, so 5 minus 3 squared plus 4, times a plus 4, and then equals negative 4. I got one variable left, solve for it. And that, again, that A is what makes this one uniquely this one. You know, it goes through that point. So I got negative 4 equals A times, and then 5 minus 3 is 2. 2 squared is 4. So this is going to be 4 times A plus 4. Subtract 4 from both sides. I got negative 8 equals 4A. And then divide both sides by 4. I'm running out of room here, but A is going to equal negative 2. So now I've got this equation, plug in negative 2, and I got my answer. So it'd be y equals negative 2, x minus 3 squared. Again, I'm back to putting x and y in here. You know, I substituted 5 and negative 4. That was a specific point. This is the general equation for all x's and y's that make this true. And then plus 4 in the end. So there would be the equation in vertex form that has this vertex and goes through that point. Given the vertex of a parabola is 1, 3, and another point is negative 2, 9, write it in both vertex and standard form. So same thing all over again. We're going to do the same thing. So y equals a x minus h squared plus k. Plug in what you know. Now you can kind of do 2 steps in one, because right here, this is the vertex. So that is h, that's k. This is the other point, so that's x, that's y. So I got 4 variables plugging into this. There's 5 variables here, so I'm going to plug 4 of them in. So my y is 9, my a I got to solve for, my x is negative 2, my h is 1, and my k is 3. So I'm kind of jumping in, I'm plugging in both points right off the bat, trying to save some time here. So I got a, now this negative 2 minus 1 would be negative 3, but squared is going to be 9. So 9a plus 3 equals 9. So subtract 3. So I got 6 equals 9a divided by 9. So a is going to equal, if I reduce that, 2/3. So write it in both vertex form and standard form. So vertex form is going to be y equals 2/3 x minus 1, right? Yeah, 1 squared plus 3. So again, remember the x and y need to be in there in your final answer. Even though I plugged in an x and a y, that was a specific point. This is for all the points. So there's in vertex form. Now to find the standard form, simplify it. Multiply it all out. So I've got 2/3. If I were to square this right here, so x minus 1 times x minus 1, you could write it over here as x minus 1 times x minus 1 and multiply. So FOIL it out. So x times x is x squared. Now the outer would be a negative 1x, and the inner is going to be a negative 1x. So that's a minus 2x. And then negative 1 times negative 1 is plus 1. Okay, so far I've squared. Keep going. Distribute the 2/3 out. So this would be 2/3 x squared minus, think of that as being over 1. So 2/3 times negative 2 over 1, that'd be negative 4/3 x plus, and then 2/3 times 1 is 2/3 plus 3. So now y equals 2/3 x squared minus 4/3 x, and 3 plus 2/3 would be 3 2/3. So there's vertex form, there's standard form. Okay, now the bottom, and a lot of this is just review. Reviewing the last couple days. This is in standard form, so I got to think back to my standard form way of solving things. I want to find the vertex. So the vertex, when it's in standard form, remember the vertex is going to be negative b over 2a comma f of whatever you get when you take, negative b over 2a. So I'm going to take negative b over 2a. So negative b would be negative 4 divided by 2 times a, which is negative 1. So negative 4 divided by negative 2, that'd be a 2. So that is the x-coordinate of the vertex. Also, that's the axis of symmetry. So x equals 2. And then to find out what this is, I need to do f of 2. So f of 2 is going to equal, so it'd be negative and then 2 squared plus 4 times 2 plus 5. This here, the negative's on the outside, so it's going to be a negative 4 plus 8 plus 5. So I've got, negative 4 of these two, that would be 13. So negative 4 plus 13 would be 9. Now, is this a minimum or a maximum? We got to figure out if it's open up or open down. So how do we do that? Well, look at this guy. Look at the a. It's negative. That means it's going to be open down. So the vertex would be a maximum point. And what is that maximum value? Remember, the maximum value is the y. So 9. Domain on this guy. Now, if maybe I'll go over here. Do the y-intercept. In standard form, remember, it screams the y-intercept at you. It's 5. So the y-intercept is 5. So I'm going to go 0, comma 5. And then the x-intercepts we learned yesterday, that's when this equals 0. Okay, so for y-intercept, we plug 0 in for x. For x-intercept, we're going to plug 0 in for y. Now, pretty good chance there's going to be 2 of them. I haven't tried this yet, but a pretty good chance there's going to be 2 x-intercepts. So I'm going to write it twice, but they're y-coordinate 0. So I'm going to put a 0 on this side. So 0 equals, and when we factor, it's best to have a negative out of there. I want x squared minus 4x minus 5. I'm going to divide everything by negative 1 and then factor this. So two numbers that multiply to give me negative 5. That means one's positive, one's negative. And when I add, I get 4. So that'd be negative 5 and 1. Product's negative 5, sum is negative 4. So that means x would equal negative 1 and positive 5. So when x is negative 1, you get 0, and when x is 5, I get 0. So there's your x, y intercepts. If you just want to do a quick sketch of this, maybe I'll put it right here. I got a My y-intercept is at 0, 5, 1, 2, 3, 4, 5. X-intercept at -1. Y-intercept at, x-intercept at 1, 2, 3, 4, 5. My vertex is at 2, 9. So let's see, 5, 6, 7, 8, 9, somewhere in here. And if that's 2 units to the left, I have to go 2 units to the right. So that'd be at 4, it'd be somewhere in here. So here I'm going to have this, just a quick sketch of what I got. Now the domain of this guy, and it goes left forever, right forever. So it'll be -infinity to infinity. The range, think from up, I'm probably from down on up. Always go negative to positive. So start low, go high. So it's going to be from -infinity up to 9, and 9's included. Intervals of increasing or decreasing, our intervals are all about x's. We don't write down x values. So over what x values is this increasing? It'd be these right here. So going from the left, going from -infinity up to 2. And then it's decreasing from 2 on, going this way. So from 2 off to infinity. It's decreasing. Okay, so let's turn this guy over. And I wrote in the 2 different forms here. So how do I find the minimum or maximum or minimum given an equation vertex form? Okay, this one, kind of cool. It's screaming it at you. Okay, because remember, vertex form, the min or the max is going to be the y-coordinate of the vertex, which is k. So k is the minimum or maximum value if it's in vertex form. If it's in standard form, a little bit more work to find that y-coordinate of the vertex. First off, you got to find the x-coordinate of the vertex. The x-coordinate of the vertex is the axis of symmetry. So -b over 2a would give you the x-coordinate. Then plug that into the formula to find the y-coordinate. So that is actually your min or the max. So you take -b over 2a, get an answer, plug it into the actual function. That's your min or max. Okay. You can tell if it's a min or a max based off the a. If a is positive, open up, so it's a minimum. If a is negative, it's open down, so it's a maximum. Okay. Example, suppose I was firing a toy rocket near a cliff. The rocket fired up okay, but then quickly fizzled out and started plummeting to the ground below the cliff. The height in meters, y, the rocket is from the bottom of the cliff at time x, in seconds, is modeled by this function right here. So when does the rocket reach its maximum height? So when it says when, think that's x value. X value at maximum height, that's going to be the x-coordinate of the vertex. Okay, so if you have x and a y, you can say h, or well, in this case it's in standard form, so h and k doesn't really help. So x and y, I want the x-coordinate, and then how high did it go compared to the ground below? What's the highest point? Now that's the y of the vertex. Okay, so if I want to find the x-coordinate of the vertex and it's in standard form, that's -b over 2a. So that'd be -70 over 2 times -5. So -70 over -10, that means it took 7 seconds. So at 7 seconds, it reaches highest point. How high did it ever go? Well, now I'm going to take f of 7. If I plug that in, I'll find my y-coordinate. So that would equal -5, 7 squared. I'm going to take 7 squared first and multiply by -5 there. Plus 7d times 7 plus 100. If you want to type in your calculator, this is how you type it in. Okay, just exactly the way I wrote it too. You do want to, if you're going to do it one step at a time, you want to make sure you square first, then multiply by 7. Then add whatever 70 times 7 is plus 100. Looks like this was 345 meters. So 345, and it says meters up here, meters off the ground. Okay, next one. You and your laptop have had the last argument ever. So you get mad, you go up on the roof and you toss it. The height, so the path of your laptop can be modeled by the y would be the height off the ground. X is going to be seconds after you threw it. So how high did your laptop go compared to the ground level? So when it says how high, it's talking about a y value. So for the vertex, we want the y value of the vertex. When did it reach that maximum height? So when is in seconds, that's your x. Oops. So that's your x coordinate. So on this one, I would find this one first. Okay, so it'd be easier for number 2 to find this one first. So the x coordinate is negative b over 2a. So negative b over 2a, sorry, it's really confusing. Negative b. So the opposite of b would be negative 20 over 2 times negative 5. So negative 20 over negative 10. So that's going to be a 2. So when did it reach? It reached it 2 seconds after you released it. So 2 seconds after you threw it, it reached its maximum height. How high was it? It's going to be f of 2. So I'm going to plug 2 in. Negative 5 times 2 squared plus 20 times 2 plus 55. And if you're going to type that in the calculator, do it just like this. And then hit enter. So this was 75. So it was 75 meters. Pretty sure if that falls from 75 meters, it's going to smash the computer pretty good. And then the last one, a video game manufacturer has daily production costs of this much. So this is the cost, where C is the total daily cost in dollars, and N is the number of video games produced. Okay, so this is just the cost to make them. This isn't the profit, this is how much it costs to make them. How many games should be produced to yield a minimum cost? So at some point, if you start everything up and you bring all your workers in and you make one video game that day, you're gonna pay a lot of money to just make one video game. So you think, well, I might as well just make 2 while we're here. I might as well make 3, and then it's gonna start going up and up. But at some point, it starts costing more because it's just the production is gonna cost too much per video game. I'm not sure why, but for some reason in this function it does. So this factory, for some reason, maybe it costs more. So at some point, the more you make, the more it costs. So we want to find that minimum point. So how many games should we produce? We know how many games. That's an n value, which in this case is your x. And then c, what's the cost? That's your c. So I'm going to find n first. And the way to find n is the same thing as your x. That's a negative b over 2a. So I'm going to have negative b, which in this case would be positive 10, all over 2 times a. 2 times a, that'd be 0.5. And if I took 10 divided by 0.5, that's actually 20. So 20 is my first answer. Put this. So how many? 20 video games. I'll write it like this. Now what would the cost be for 20 video games? Take f of 20. So that would be 0.25 times 20 squared minus 10 times 20 plus 800. Okay, so type it in just like this. If you can see everything there. So type it in just like this. Hit enter. 700. So it would cost $700. So $700. Please remember, update your learning log. Go back and look at all the dates and see if there's anything you can update.